In another video, we discussed Fourier's theory, which essentially states that all sounds are made up of sums of sine waves. In this video, we will investigate the type of synthesis that is related to this theory, additive synthesis. There are many types of synthesis. In other videos, we have seen subtractive synthesis, which uses filters to subtract harmonics from a tone, and FM synthesis, which uses the frequency of one oscillator to modulate the frequency of another. But while subtractive and FM synthesis can be done with just a couple of components, additive synthesis requires many more components to start creating interesting sounds. As the name would suggest, we are going to create sounds by adding waveforms. One of the oldest examples of additive synthesis involves the organ, starting with the pipe organ, which dates back to ancient Greece. The technology is simple: air moving through pipes. Some pipe organs can have hundreds of different pipes, and combinations of these pipes, through addition, generate the complex tones. In the 20th century, a new type of organ was invented, the tone wheel organ. The technology behind a tone wheel organ is spinning discs whose sound is amplified through electronics. The most famous of these is the Hammond organ, which supplies 9 waves that can be added. Another interesting feature of the Hammond organ is control over the amplitude of each of the 9 sine waves. This allows for millions of possible sounds. For example, we can add the first 6 harmonics of a fundamental using 6 drawbars on the Hammond organ. As I increase the amplitude for each, we can see an increase in the complexity of the resulting waveform. If I decrease the amplitudes for the higher harmonics, we can start to approximate a sawtooth waveform. Synthesizers are another type of electronic instrument that can create sounds using additive synthesis. But, since they are physical instruments like the organ, they can be limited by physical realities like space and cost of materials. Early analog synthesizers from the 1960s and 70s only had a few oscillators which could produce the waves needed for summation. For example, in the video on the Fourier series, we can see the use of 4 sine waves from a Moog modular synthesizer from 1974 to approximate a square wave. The late 1970s and early 1980s saw the production of digital synthesizers, which could do more in the realm of additive synthesis. One of the first of these is the Fairlight CMI, which found a lot of popular use due to its sampling capabilities. But its additive synthesis capabilities were powerful, with the ability to use 32 harmonics of a fundamental to create sounds. Later incarnations also gave the ability to use a fast Fourier transform to convert a sample of audio into synthesized harmonic partials. This is the reverse of what was demonstrated in the Fourier series video, as it is the decomposing of a complex waveform into sine wave partials. We can recreate this with a software emulation from Arturia. Fourier transform. Fourier transform. Fourier transform. Fourier transform. Fourier transform. What we can see in this example is the original audio file synthesized with 32 harmonics, each with varying amplitudes. It does not sound like the original, as that would require many more harmonics, but it does give us insight into how additive synthesis can work. Another early digital synthesizer was developed by Hal Alice for Bell Laboratories to test telephone communications in the 1970s. But the same machine could also be used to synthesize acoustic instruments, much like the pipe organs described earlier. In fact, a few years after Alice invented his synthesizer, a similar synthesizer, the Krumar GDS, was used by Wendy Carlos for her score for the movie Tron. Additive synthesis has shown up in a unique way in other forms of entertainment, through an auditory phenomenon called the Shepard tone. The Shepard tone starts with notes separated by octaves played at the same time, with a center pitch that is louder than the lower and higher pitched notes. As the octaves move up in frequency, the lower pitched notes increase in volume as they reach the center, and then decrease in volume as they are raised higher in pitch. The notes repeat this pattern, but the end result sounds like there is an infinite increase in pitch. I can recreate that with the same telharmonium module that was used in the harmonic series video. This same sound was used to create the sound of the motorcycle ridden by Batman in The Dark Knight, which has the sound of infinite acceleration. Here are some other uses of additive synthesis in recorded history.